All right, when we talk about functions, oftentimes we talk about fairly simple functions. One more technical function, though, is what's called a piecewise function. It just looks very technical, such as that function up top. F of x will be equal to x minus 4 when x is less than 3, but also f of x could equal 2x instead when x is greater than or equal to 3. Now, don't let that monstrous looking function sort of throw you off, that two options thing. We're basically just saying it all depends on x. So notice in our first option, f of 0, again, we're saying that x is going to be 0. So the first thing we need to decide is which of the two parts do we want to use. If x equals 0, then 0 is less than 3. Well, I want to use this first idea, which means I'm going to use that first function. So when I go down to plug that in, again, I'm going to take out x, and I'm going to say minus 4, but instead of x, I'm plugging in 0 here. So 0 minus 4 would be negative 4, and f of 0, just like a function should, one answer, f of 0 equals negative 4. Along those same lines, what if x is 10? Well, now 10 is greater than or equal to 3. We're going to use the second piece, so that 2x, I'm going to say 2 times my x value being 10, and therefore my answer is 20. And again, we basically just found the coordinate. When I plugged in 10, I got back 20, and life is good. Every input has exactly one output. How about f of 3? Let's take that 3, again, head over to that right side. The first thing we need to decide is which of these two functions, right, do we want to use? So the first thing we have to look at, oops, erased part of the problem there. The first thing we need to look at is where would 3 fit? Is 3 less than 3, or is 3 greater than or equal to 3? And because it's greater than or equal to 3, we're going to use that 2x. So again, 2 times 3 equals 6, and we've got our answer. Again, we're not going to plug it into both options because it only really fits in one of them. Over here at the right, we've got sort of that domain, or what's oftentimes called the constraint of the problem. We only plug x in when that constraint or that domain fits, when the constraint is true. Now we can work the problem backwards as well. What if we had a problem like this? You're ordering some homecoming t-shirts. You want to order fewer than 50. You'll get, I'll have to pay 12 bucks. But if you order more than 50 shirts, 50 or more shirts, be very specific, 50 or more, the additional t-shirts will only be $5. Well, we can set up a couple of functions. The first idea, well, it's $12 a shirt. So I would just say $12 times x, the number of shirts. But for the second option, I would say something more like this. 588 is basically saying, well, hey, we have to order the 50 shirts. 50 shirts are going to be 12 bucks per shirt. 50 times 12, 588. Which, as you notice, that doesn't seem quite right, does it? Oh, wait a minute. 50 or more, the additional shirts are only $5 each. Well, remember, this only worked for fewer than 50 shirts. So actually the first 49 shirts cost $12. 49 times 12. Well, that's your 588. That's a guarantee though, because again, in the second option, we're ordering 50 or more. The first 49 shirts are a guarantee. We're gonna pay 588, but then we're gonna pay an additional, notice add on, right, plus 5 times every shirt over, right, minus over that 49 initial shirts. So we'll pay the initial 588 plus $5 for every additional shirt. The 50th shirt costs you $5. The 51st shirt costs you $5, and so forth. So again, a great time to use a constraint. We're going to pay $12 per shirt for the first 49 or fewer shirts, right? But we're going to pay $588 plus $5 per shirt for anything over 50 shirts. Hopefully that makes sense for you. Again, that's just a great way to look at piecewise functions. Again, if you have any questions, make sure you talk to your teacher. Otherwise, have a great day.